we will be exploring the long-term effects of subduction zone earthquakes. These powerful seismic events occur at tectonic plate boundaries where one plate dives beneath another, a process known as subduction. The forces involved in subduction create some of the most intense earthquakes on Earth, leading to significant short and long term impacts on both environment and human society. Subduction zones are convergent plate boundaries where an oceanic plate sinks below a continental or another oceanic plate due to differences in density. This process builds up intense pressure along the fault line until it's released in a massive earthquake, often go together with aftershocks, tsunamis, and significant crustal deformation. Subduction zone earthquakes cause extensive crustal deformation, which can always change the landscape. Coastal area may experience uplift or dropping, as seen in the 1964 Alaska earthquake, which resulted in parts of the coastline permanently rising or sinking. Repeated subduction events may lead to the formation of new faults or fractures in the Earth's crust, adding complexity to the local and regional fault network. This modification affects the distribution and behavior of future seismic activity, often increasing the probability of earthquakes along these newly formed or reactivated faults. Subduction zones are closely associated with volcanic arcs, and the stress changes from major earthquakes can influence volcanic activity. Over time, the shifting of magma within the crust due to earthquake-induced stress changes can lead to increased volcanic eruptions, adding another dimension to the long-term geological impact of these events. Subduction zone earthquakes often trigger tsunami, which have a deep impact on marine and coastal ecosystem. Tsunami can destroy coral reef, mangroves, and seagrass beds, disturbing the habitats of countless marine species. The movement and shaking associated with these earthquakes often lead to underwater landslides, significantly redistributing sediments in the ocean. In subduction zones, earthquakes may permanently change soil structure and groundwater system. Groundwater aquifers can be disturbed, leading to changes in water availability and quality. Earthquakes in subduction zone frequently cause extensive destruction of infrastructure, including homes, roads, and utility networks. The reconstruction process can take decades and require large financial and labor resources. The data gathered from large subduction zone earthquakes contribute to improvements in seismic hazard models. However, each earthquake provides new insight, often requiring revisions to these models. Improved understanding helps communities in other subduction zones better prepare for potential risks, mainly in terms of land use planning and construction practices. In conclusion, subduction zone earthquakes have durable effects that transform landscapes, disturb ecosystems, displace communities, and other impacts. These long-term consequences highlight the complex ties between natural system and human society. By advancing hazard assessment, early warning system, and conversion efforts, we can better understand and reduce these impacts, fostering resilience in earthquakes prone areas.